Shalom to you. Welcome. In this video, we'll be working with logarithmic functions, basically solving logarithmic equations. We have just finished working with exponents, solving exponential equations. Remember that exponential equations and logarithmic equations or functions are inverses of each other. Okay, so we remember when we were solving exponential equations, sometimes we would need to take the log of both sides when we cannot find a common base. Okay, so let's do more of solve basically logarithmic equations applying the laws of logarithm, which are similar to the laws of exponential functions. Okay, so if this is an exponential function or equation, this will be the inverse, which if you solve for y, you get this. Okay, this is just when you switch x and y. And then this is when you solve for y. Why? Because you have to take the logarithm of both sides to bring down the exponent. Logarithm always brings down the exponent to the down. Okay? So you need to remember that just like in the exponential function, b cannot be, the base cannot equal 1, and the base has to be greater than 0. It cannot be negative. So when you solve a logarithmic equations or problems and then get a negative b or x, then the answer is extraneous. We just reject it, okay? Another thing to remember, whenever we write the log of base 10, we do not usually write that base. We just ignore it. So in your calculator, what the calculator is automatically inbuilt is base 10. So that's why whenever you take a log in the calculator, so that log is in base 10, except if you specify a different base in a graphing calculator. Okay. So the laws of logarithm you need to remember, this one, the first one, foremost, this is the one that changes an exponential function to logarithmic functions, but both of them are equivalent, and I will show you in a minute how that come about. Okay, and then of course, just like in the exponential function, when the base are the same, then their exponents must equal each other. Okay, so we can use that to solve equations. So let's look at an example. First of all, let's show how this exponential function come to become this. Let's solve it. Okay, let's try to solve for x, because this here x is solved. Okay, so if we solve for x, that means taking log of both sides in the same base. Let's say base b, because this is the base is b. The base is the same whether it is in the logarithmic form or the exponential form. You retain the same base. If the base for the exponent is b, we take log base b. Log y of base b is gonna be log b of base b, log b to the x power. So now, whenever the rule of law, logarithm say once we take the base, the exponent comes down to multiply that log. Okay, so that equals x log b of base b. And this log b of base b is 1. Okay, so if log y b of base b is 1, so this is x times 1. And so x times 1 is x. So that's it. You look at that, then you look at that, or this, they are the same thing. Okay, so that's how that came to be. So these two expressions or equations are equivalent. They are equivalent. It's just like saying, okay, 1/2 is equal to 0.5 or is equal to 50%. they are equivalent but in different form. 1/2 is in fraction, 0.5 is in decimal, 50% is in percent. So, but they have the same value in their different forms. So that is the exact same thing we are saying here, that this expression is equivalent to this expression. This is in exponential, this is in logarithm. Okay, now let's look at an example. All right, let us look at this equation. 3 log x of base 2 minus 5 equals 1. Again, follow the same process of solving equations. Simplify each side of the equation first. Whatever you can simplify before you get to the log part. So here we have two terms. Okay, 3 log x base 2 and then minus 5. So we can add 5 to both sides. So get all the numbers to one side. Okay. So the same process of solving equations, we do the same thing regardless of, we follow the same procedure regardless of what type of equation we are solving. Okay, very good. So each step makes it simpler, makes it look simpler. So that 5 is gone. So now what do? There is only one term here, but this is 3 times log. So we can actually get rid of this 3 by dividing both sides by 3. We divide both sides by 3, this will cross out, we will get log base 2 of x is equal to 3 go into 6 is 2. Okay, now there's nothing else we can simplify. This is the log and the number on the other side. So how do we solve for x? Well, there's no log on this side and there's no exponent. So we can write this to exponential form. We remember that identity 1. So if we identity of multiplication. So if we multiply this by 1, 2, 2 times 1 is still 2. So if we bring down the log, make this one become log. Okay, so log of the same base. So this is, since this is in base 2, we want to make it log 2 of base 2 because log 2 of base 2 is equal to 1. Okay, so substitute 1 with that. So this is log of base 2x. We just keep the left side. We're not doing anything with that yet. So doing this, when you multiply the log, remember that process by a number, it goes up. So this is log 2 of base 2 to the power 2. So that 2 goes up. Remember, whenever we take the log of both sides, the exponent comes down. So now you multiply the number with a log, it goes up. It's just the reverse of that process. So now that this goes up, this is log of base 2 and log of base 2. When the log is the same, so that crosses out. You can do both sides by each other. So we're going to have x is equal to 2 to the second power. Okay, so 2 to the second power, which is 2 times 2, which is 4. Done. Okay. Right, here's another one. Now, in this one, the exponent, the base is the variable. Okay, but the same procedure, the same process. Okay, let's try that. So now there's no exponent. So we want to there's nothing to simplify. So we want to multiply this by 1 and then replace that 1 with, since we have the base of x, we're going to make it be log of x of base x. Okay, so log of 64 base x on that side. So now that will go up. This will go up. That becomes log of base x, x to the power 3/2. Okay, so now the logs of x can cross out each other. If you divide both sides by that, so we have 64 is equal to x to the power 3/2. So now, since the variable is at the base, so we try to make the exponent be the same, but it will be difficult. It will be more difficult to make this exponent, find what you can multiply by this exponent to get 64. So the easiest one is try to make this exponent to be 1, to equal 1. And what will make it 1 is the reciprocal. Reciprocal of 3/2 is 3/2. So multiply both sides by the reciprocal of 3/2, which is 2/3. So you multiply this by 2/3. So we're gonna make this exponent 2/3 also. So the exponent for the 64 is 1. So you multiply that, you get the same thing. So this crosses out, and we have x equal 64 to the power 2, 3. And so x is by itself, so we just need to simplify this side. And remember that you can write this as a rational, so which will be a cube root. The root, the r, the denominator is the root. Okay, and then the base is still the radical, the base. And then this the power, the exponent, you can write it on top or inside. Both will give you the same thing. Okay. So what's the cube root of 64? What can multiply itself 3 times and get 64? Okay, we can use our calculator. Okay, and I think it's 4, but let's try. Okay, so 4 times 4 times 4, multiply 4 3 times, that's it. Okay, so 4 times 4 times 4 is 64, so we can make this to be 4. Then we bring down the square. Okay, so equals x. Then 4 times 4 is 16. And that's solved. All right, let's look at another problem with natural log, where we can apply the rule of multiplication and addition. Okay, it says whenever you're multiplying two natural logs, you can add them, distribute the log, natural log, and add them. So if you have, or vice versa, if you have the addition, you go. So let's look at this problem with that. So here we have the natural log of this plus the natural log of this equals that. So if we have this, we can, since we are adding them, we can just multiply them. So the ln, so we can multiply this times that, and then this and that. X plus 4 equals to natural log of x. So we have polynomial here. So we need to distribute and then collect like times 4. So x times x is x squared. X times 4 is 4x. Negative 3 times x is negative 3x. And negative 3 times 4 is negative 12. Okay, equals 2 times natural log of x. So next we go on simplify that parenthesis. So x squared, 4x minus 3x is 1x. Then minus 12 is equal to 2 natural log of x. Okay. So what do we do next? Well, there is there's x here, there's x here, so we can actually collect like terms, or distribute. Let's distribute this first. We distribute this first. So we have natural log of x squared plus natural log of x minus natural log of 12 equals 2 natural log of x. And actually this one, since 2 is multiplying the log, we can actually put it in the exponent. Okay, so that will make it, I'll do that right away. So that would make these two, because these two are going to be like terms. See, they are like terms, so they can actually cross out each other, or just subtract them, because this is one of it. Okay, subtract it from both sides. This will become 0. So we have n of x ln of x, and we can actually add this one from both sides. Okay, so that will get it out of here too. So we have natural log of x is equal to natural log of 12. Okay, that makes it simple. I hope you got this. We crossed this out. We added this to both sides because this becomes 0 here. So, but with this, we have that natural log of 12 there. So now what's next? Hey, we have our answer actually. This is natural log can cross out natural log. We just have x equals 12. Look at that, how easy that came out. Okay.